Hello students, in our last class we discussed about bases and we discussed about acidity of a base. What does it mean? We have seen its classification. After that we have seen the preparation of bases, and then we have seen physical properties as well as the chemical properties, that means the different chemical reactions of bases. Now today we are going to see general uses of bases. That means where you find the use of base. Say for example, sodium hydroxide is used in the manufacture of soap. Potassium hydroxide is used in the manufacture of salts and soaps and are also used in batteries. Calcium hydroxide, which is also called as slaked lime, it is used in the manufacture of bleaching powder and softening of hard water. Whereas magnesium hydroxide, which is also known as milk of magnesia, is used as an antacid, neutralizes acidity. Whereas aluminum hydroxide is used as a foaming agent in fire extinguishers. And ammonium hydroxide is used to remove grease stains from clothes. And magnesium oxide is used in making refractory bricks, and calcium oxide is used in drying agent or as basic flux. Next we have got the topic test for acidity and alkalinity, how to identify which solution is acidic and which one is basic, okay, or which one is neutral. So the acidic, basic or neutral solutions can be tested by common indicators like litmus, methyl orange and phenolphthalein, as we have seen previously. Now over here we need to know what does pH means, because pH determines the acidity, basic or neutral solution. So pH stands for power of hydrogen, or the definition of pH tells us the pH of a solution is the negative logarithm to the base 10 of the hydrogen ion concentration expressed in moles per liter. That means if you go for the expression for pH of a solution, it is given by, or the definition is given by, pH is considered as negative of logarithm with respect to base 10 of hydrogen ion concentration, or pH can also be written as log 10 1 by H plus. So when you take this to the numerator, it becomes to the power minus 1, and according to the logarithm formula, that minus 1 will come in front. So pH will be equals to minus log 10 H plus. So this is the equation for pH. Now by using this equation, we can also calculate what is the pH of the given solution if the H plus ion or hydrogen ion concentration is given. Say for example, a numerical has been provided over here to show the calculation how we can calculate the pH. A solution of H plus ions of concentration equal to 10 to the power minus 12 moles per liter is given, will have pH equals to 12. So that is pH equals to log with respect to base 10 1 by H plus, which is the formula that is given. And after that, what we have done is we have replaced this H plus with this value 10 to the power minus 12. Okay, got it? Now this 10 to the power minus 12, when it goes up in the numerator, since in the denominator it becomes positive 10 to the power 12, 10 to the power 12. Now according to the logarithm formula, if we have got something in the power, then we can bring it in front. So 12 will come in front, log 10 10. Now once again we have got the formula log, if you have got the log this base and this same, log 10 10, its value will be always 1. If it is 5 5 also, the value will be 1. If both are same, then its value is 1. So over here it's equal to 12 because this value is 1. So this is how we can calculate the pH of a given solution if the hydrogen ion concentration is given. Now the normal pH ranges from 0 to 14. Okay, it has got the value from 0 to 14. So you can see the pH scale over here, it ranges from 0 to 14. Now over here from 0 to 7, it is considered as the solution. If the pH value ranges from 0 to 7, below 7, then it is considered acidic. And it is, if it is from above 7 till 14, it is alkaline, or we call basic. and if it is exactly 7, then it is a neutral. This is how we can determine the pH of a given solution from their values. Now there is a term called universal indicator. Universal indicator is a mixture of indicator dyes that gives a spectrum of colors depending on how acidic or alkaline a solution is. Universal indicators give different colors at different concentration of hydrogen ions in a solution. So universal indicators give different colors at different concentration of hydrogen ion in a solution. So universal indicator is a mixture of dyes depending on how the color changes depending on acidic or alkaline solution. For example, a universal indicator produces green color in a neutral solution, that is when pH is 7. It changes in a basic solution progressively from blue to indigo to violet as pH increases progressively from 7 to 14. And similarly, the color change in acidic solution is from yellow to pink and then to red as pH progressively decreases from 7 to 1. So from the pH indicator or universal indicator, from different colors we can predict the pH of that value. Next we have got importance of pH in everyday life, where you'll find the use of this. So our body works with a narrow pH range of 7.0 to 7.8. Plants and animals also survive in this narrow range. In agriculture, if every crops grow better in a particular pH range. For example, rice grows better in slightly acidic soil, sugarcane in neutral, and citrus fruit in alkaline solution. Over here in agriculture, pH also matter. If pH is less than 5.6 of rainwater, it is said to be acid rain. And this water contains acids like sulfuric acid, nitric acid, carbonic acid, which are found by atmospheric pollutants, mainly sulfur dioxide and oxides of nitrogen. Acid rain reduces fertility of soil, destroys marine life, and causes damage to monuments. pH is also find use in medicine. Certain diseases are diagnosed only on the basis of the pH value of blood and urine. It is used in digestive system, as I've explained, for neutralization. Say for example, in your body, if the HCl production is excess, then it will cause you pain and irritation, and that we call it as gastritis or gastric. At that time we take antacids which will neutralize that acid. So antacids, milk of magnesium, which is magnesium hydroxide. It is also used in preventing tooth decay. Substances like chocolates and sweets are degraded by bacteria present in our mouth. When the pH falls to 5.5, tooth decay starts. So tooth enamel, calcium phosphate, is the hardest substance in our body and it gets corroded. The saliva produced by salivary gland is slightly alkaline. It helps to increase the pH to some extent, but toothpaste is used to neutralize excess acid in the mouth. And the last one is bee sting leaves acid in the body. If baking soda or base is applied on the stung area, it gives a relief. So as we know, bee sting generally removes acid which causes pain in our body. So in order to relieve it from pain, we need to use baking soda, which is a base. So that is a neutralization process.